Welcome back, Mariners. In today's video, we are going to learn about the celestial sphere and the related terms to it. So my name is Abhilash Thakur. Let's start the video. So the celestial sphere is an imaginary sphere, okay, which is all around the Earth. So all of your celestial bodies like stars, planet, sun, moon will be in this celestial sphere only, okay, just like a universe, right? So what we consider that the Earth is at the center of the celestial sphere and it has a radius which is infinite. Okay, it has no measurable length. It is infinite sphere which has infinite radius, sorry. So that is what the celestial sphere is. So all of your stars, planets, it will be around somewhere here. So in celestial sphere, what we consider that the Earth is not moving as it is at the center of the celestial sphere. All other bodies move around the Earth and Earth is stationary, it is not moving. This principle we use for the navigation calculations. It is much easier to do this way, but in actual scenario you already know the Earth is not stationary, it is moving, it is revolving around the sun, and also it is rotating on its own axis. So but here what we consider that all other bodies are moving, not actually the Earth. Okay, so now the question is why we need the concept of the celestial sphere. Well, you already know to get the position we need fix, right? We need position lines. So when the two position line where it intersects, we will get the fix. Fix means the position of your vessel, right, or of yours, right? When we use the land objects, let's say a lighthouse or whatever, and another lighthouse, when you get two bearings intersecting at one point, this will be your position of the vessel, correct? But out at sea, there is no landmark. Then how you will get the position line? We will use the celestial bodies like sun. At night time we can use stars, we can use moon. These are the celestial bodies which we can use to get the position line, and where two position line can intersect, that will be your position or your fix, right? So to get the position line, you need to know where these objects are. Like on the land, we need to know that this is the lighthouse and where it exists on the chart, correct? But here we need to know where this body is at the celestial sphere. We need to find out the coordinate of that body. So where does it exist? It exists here, here, or here. Where it is exactly? If we know it is here, then we can get the position line, correct? So that is what we use this celestial sphere for. We use it to identify where our celestial body is, whichever body you are using to get the position line, we need to know where it is with respect to the Earth. Okay, so that is the point of the celestial sphere. So now let's understand the coordination system of the Earth first, then we will move on to the celestial sphere. Alright guys, now I have drawn the rough diagram of the Earth. So you already know what are these? These are the poles. So this is North Pole, this is South Pole, correct? And what is this? This is equator. You might know already these things, very simple. This which divides Earth into east and west, we have considered this one as Greenwich meridian. Why the name Greenwich? Because there is a place known as Greenwich in United Kingdom from where it passes through. It is not the actual line, it is an imaginary line, but the place name is Greenwich, right? So this is 00 degrees, this is also 00 degrees, correct? And what are these? These are latitudes. These are longitudes. We already know this thing. So to know the position of any object or the observer or yourself, we need to know the latitude and longitude, correct? This is what we need to know for the position of anything on the Earth. So whatever the things which we have learned here, we will transfer these things to the celestial sphere. Alright guys, now I have made the celestial sphere. We will transfer all those things to project all those things to the celestial sphere. So this is North Pole, of course. This is celestial North Pole. Okay, we transfer this thing to the celestial sphere. This is South Pole. This is celestial South Pole. Very simple. Now we will make the equator. Right? What is this? This is known as equinoctial. This is basically the projection of the equator onto the celestial sphere. So what equinoctial does? It divides the celestial sphere into two halves, that is North Hemisphere and the Southern Hemisphere, just like an equator. Okay. Let's say this is Greenwich meridian, same we will transfer it to the celestial sphere. This is also known as Greenwich meridian. These are longitudes, correct? We call these celestial meridians. So the longitudes are converted to the celestial meridians. Okay. Now we have latitudes. On the earth, same things we will transfer here. These are known as declination. But basically what we call them, declination circles, because they are circles like this in 3D. Same like latitudes. Latitudes in the navigation terms we call them parallel of latitudes. They are parallel to each other and they are small circles. What small circles are? Small circle means that their plane is not passing through the center of the earth. As the center is here, this plane of this, you can see the disk, that is the plane of the circle, and that is not passing through the center of the earth. That is why they are not great circles, they are small circles. And what great circles are? Great circle means that the plane is passing through the center, like equinoctial or equator. They are passing through the center of the earth. The plane of the circle is passing through the center of the earth. Okay, so these are called as great circles. So now one more thing we will cover here, that is GHA. Now what is GHA? GHA is Greenwich hour angle. Let's say for an example, this is the sun. This is a celestial body. Well, you already know that for the position on the earth we need latitude and longitude. For the position on the celestial sphere we already have the declination, right? We know these things. But for this part, what we need, let's say that is GHA. Okay, so this is the Greenwich meridian, correct? And this is the meridian of the body, of the celestial body, right? Now Greenwich meridian, from Greenwich meridian to the celestial body, this is the angle between them. This is Greenwich meridian, this is the body meridian, and this angle is known as GHA. From Greenwich to the body, the angle between the meridian of Greenwich and the body, very simple, that is known as GHA. And one more thing is additional here, that it always measure westwardly from the Greenwich. Okay, so this will be GHA, this will be the declination. Now we know where the body is on the celestial sphere. Let's say this body is here now, the sun is here. You can see the declination is the same, there is no change, this is the declination. But the meridian has changed, right? So this is the celestial meridian now, this one. So what will be the GHA? Not this one. GHA always measured westwardly. So from Greenwich, from west to this meridian, this will be Greenwich, GHA. This will be GHA. So GHA is obviously more than 180 degrees. Of course, this is a semicircle is 180 and more than 180 degrees. So this is all around 240, 260, whatever. Okay. So GHA value can be from 0 degrees to 360 degrees. Well, 360 and 0 is the same. So you can write 359. Okay. So this can be from 0 to 359. But on the other hand, longitudes are from 0 to 180 degrees. They are either east or west. So half of them cover the east, half of them cover the west. So total value will be 360 degrees. But here the value is from 0 to 359. Okay. So once you know the declination and the GHA of the body, you know where the body is. It's as simple as that. Alright guys, now we will cover up one more concept here, that is the concept of ecliptic. What is ecliptic? Ecliptic is a path of the sun around the earth. Well, actually this is the path of the earth around the sun, but here in the celestial sphere what we consider that the earth is not moving but the sun. So you can see here this is the equinoctial, right? Well, in school what we have learned that the sun is in the center and this is the orbit of the earth, right? And this is a 2D image, but in actual terms this path is not straight like equinoctial. It has some tilt, okay? And that is known as, that is the angle between the equinoctial and that is known as obliquity of ecliptic. Okay, this is known as obliquity of ecliptic. This is the angle between the equinoctial and the ecliptic plane. Okay, this angle, and this is about 23.5 degrees approximately, the obliquity, this angle. Okay, so you can see here the declination of the sun is changing here. These are the declinations, right? We have already covered. Now the declination here is this. So the sun is going from south to 0, then again north, then again 0, then again south. So the declination is changing as the days go by. So every hour it is changing little by little. Okay, so the maximum declination south will be here, right? And the maximum declination north will be at this point. At these 2 points, the declination of the sun will be 0 because it is actually on the equinoctial, and the equinoctial, the declination is 0, right? So this maximum declination is 23.5 degrees approximately. This will be 23.5 degree north, and this will be 23.5 degrees south. This is the approximate figure, 23.5. Okay, so the sun will go south, 0 north, then again 0 south. Alright guys, you can see it here that the ecliptic and the equinoctial are intersecting at 2 points, this one and this one. Okay, so when the sun is going from south to north and it is intersecting to the equinoctial, this point is known as first point of Aries. And another one, when sun is going from north to south and intersecting at the equinoctial, this is first point of Libra. Well, most of the time in navigation we use this reference point, that is first point of Aries. So that's why you need to know that what is the first point of Aries. It is simply the intersection of the ecliptic and the equinoctial when sun is going from south to north. Alright guys, that's it for this video. I will make 3 parts on this video because this concept is a little bit longer, and you need to watch this video again and again so that these concepts, these diagrams basically get into your mind and it get picturized in your mind. Okay, because you need to understand the basics first, then only we can move on further. And in the next video we will cover up the equinoctial system, in which we will learn the GHA, SHA, RA, and what is this terms and what are the definitions of it and how this definition has been formed, okay, by the help of diagram. Alright guys, if you find this video helpful, you can press the like button and do subscribe this channel. Also press the notification bell so that you don't miss out the videos which are coming up next, and do share this video to your friends also so that they can get thorough with the navigation concepts. Also, if you have any questions regarding the navigation or anything regarding the merchant navy, you can put down in the comment section below. I will try to answer it there, or I will try to make a video on it. Alright guys, so I will see you in the next video. This is Abhilash Thakur signing off.